All right, so let's talk about going after the Northern Lights. And what I'll do today is kind of give you a little bit of the uh, history and what is the Northern Lights, what are the Northern Lights, and how do you go about seeing them, and what does it actually look like? That was one of the things that I was most curious about before Jane and I took this trip in this wintertime. So hopefully what we're going to show you here is pretty much what it actually looks like when you're on the ground and looking up at the sky. Okay. So, you know, it was interesting. I was reading some research about when were people first studying the Northern Lights, and there was one scientist back in the 1700s who was convinced that nobody had ever seen them before 1700 AD. And in fact, we're thinking now that maybe some of these Cro-Magnon paintings of what people called macaronis may actually be representations of the Northern Lights in the sky from cave paintings from 30,000 years ago. And they actually showed up references to them in some of the court records of King Nebuchadnezzar of Babylon from 500 some years BC. It could even be referenced in the Bible in Ezekiel 1. There's a verse that says, "I looked and I saw a whirlwind coming from the north, a great cloud with fire flashing back and forth and a brilliant light all around it. In the center of the fire was a gleam like amber, and within it was the form of the four living creatures. In the midst of the living creatures were the appearance of glowing coals of fire or of torches, and the fire moved back and forth between the creatures. It was bright, and lightning flashed out of it. The creatures were darting back and forth as quickly as flashes of light," which actually sounds very much like the aurora kind of things. They were seen in Europe. These are some of the first pictures that people tried to represent them. This was one from Bohemia in 1570. And the description that accompanied this picture was that first a very black cloud passed like a large mountain on which stars had appeared above the black cloud, and a very large and long lights glowed like burning sulfur. The black cloud was shaped like a ship and made of this light or glow that, like as many torches are burning. Between them stood two large bright pillars, one in the east and the other in the upper horizon, and the city below it was lit with this great light at the sky that burned with fire, like during the day, and the two big pillars. It was seen that from their upper parts sprinkled a blood rain. After midnight, the whole scene disappeared. Here's another view of the Northern Lights seen from Nuremberg in Germany in the 1500s. Now, it was Galileo who came up with the term aurora borealis in 1619, and he took it from Aurora, who was the Roman goddess of dawn, and Boreas, who was the Greek god of the north wind. So he actually did see the aurora from Italy a couple of times. And he was the first person to come up with a scientific explanation for it. He thought that the auroras were caused by air that was rising up out of the atmosphere and coming up out of the Earth's shadow and was catching sunlight. Benjamin Franklin even wrote a scientific paper about the auroras, and he presented it at the French Academy of Sciences in 1779. He wrote the paper both in English and in French. He correctly guessed that the aurora must be some sort of electrical phenomenon, but he thought it was from a charge that was building up on falling ice and snow at the poles. So he got the electrical part of it right, but again, thinking it was an atmospheric type of phenomenon. Edmund Halley in 1716 suggested that he thought there might be a correlation between auroras and magnetic storms. People were just starting to study magnetism back then. And then Celsius and Jordan were able to use a compass to demonstrate that relationship between auroras and activity of geomagnetism. They were watching the compass needles move during auroral storms, and they thought actually that the compass was attracted to the aurora. In 1770, James Cook saw the same thing down at in the southern hemisphere, and then we realized that the auroras were at both poles. John Carl Wilke observed finally that the rays came along magnetic field lines. He was studying magnetic field lines with a compass and saw that the aurora tended to follow those magnetic field lines. And then in 1790, Henry Cavendish used triangulation and was able to figure out that auroras were somewhere between 52 and 71 miles up in the atmosphere. the real scientific research behind auroras began in the 1800s, and the French sent an expedition to the northern part of Norway. The La Recherche was the name of the ship that went up there, and they were measuring both the magnetic field and the aurora. And you can see some of the pictures that came out of that expedition on the right-hand side of the screen here. There's some really the first detailed pictures of what the aurora looked like. And then the world had its first international polar year in 1882 and 1883, when they set up polar observatories around Russia and Norway and Canada and Greenland to study what was going on both with the auroras and other aspects of trying to get to the North Pole for the first time and understand what was really going on at the poles. Now, it was Christian Birkeland who came up with the idea that there was a relationship between magnetism and electrical particles that were coming from somewhere. He figured coming from the sun, and so he created what he called a terrella, which was like a little Earth, which was basically an electromagnet inside a vacuum, and then he bombarded that with electrons and was able to come up with something that looked very much like auroras. At the same time, Carl Sturmer, who was one of his colleagues, there's actually Birkeland is on the right in this picture writing on the observations, but Sturmer was the first one to accurately triangulate how high the auroras were. He had him and another observer, and you can see the clock over on the left-hand side of the screen there. They made sure they were looking at the same formations, and they were talking by telephone so that they were able to triangulate exactly how high the aurora was. And so he was able to figure out that it was never any lower down than 80 kilometers and rarely got above 250 kilometers in height. And he took tens of thousands of pictures of auroras with film cameras in the course of several decades. You know, it was interesting after Birkeland came up with his theory about you know, that auroras were caused by magnetism, or the interaction of the magnetic field with particles. It took about 60 years for that to finally get proved. And we know now that, you know, when there's a big solar storm, you know, a chunk of magnetic plasma, it gets ejected through a coronal mass ejection from the sun. It travels at very high rate of speed, gets to Earth about 18 hours later, and then if the polarity is opposite from the Earth's magnetic field, it'll get absorbed. It'll follow the magnetic lines down into the magnetic poles. And so the stuff that's coming directly from the sun is a daytime aurora. The stuff that passes on to the tail end of the Earth's magnetic shield, when that snaps closed, that falls back to the Earth as nighttime auroras. And so these particles spiral down along the field lines, and that's how we end up seeing these charged particles hitting the ions of the upper atmosphere. You know, real briefly, you know, the colors of the aurora. Well, actually, let me stop and just ask if there's any questions before I go any farther. Is everybody hear okay and see okay?
Yeah, you're doing good.
Okay, great. All right, so you know, the auroras come in different colors, and we've seen photographs of them, and actually the colors come from the different types of elements that the ionic particle, or that the energy is interacting with. At the low altitude, there's a predominance of nitrogen, both molecular nitrogen and then ionized nitrogen molecules. And when, you know, when a electron hits, or a charged particle hits an ionized nitrogen molecule, it produces a deep blue or purple photon. If it hits an unionized nitrogen molecule, it produces an active red or deep red. And so our eyes combine the blue and the red, and they make this pink color. And this is actually the brightest color of the auroras, but it's not one that we see very often. It's usually only the most intense storms that the energized particles get that far down into the ionosphere. And this is right at the top of the right at the very bottom of the ionosphere that this happens. But when it does happen, the pink becomes the predominant color that we see. most of what we see when we see auroras is this lime green, and this is the result of nitrogen being ionized to N2 plus, which creates a light blue photon. The electron that gets knocked off of there hits oxygen, which causes it to get excited, and then when the oxygen molecule gets de-excited, it emits a photon that's in the lemon green end of the spectrum, and so we see both the light blue and the lemon green together, and we get this lime green color. And this is where we predominantly see most of the auroras, between about 100 and 250 kilometers high. And then when you get higher up into the ionosphere, you get this, obviously there's a lot less going on up there. You've got just singular oxygen atoms that are floating around. When they get excited and then lose energy in a low energy de-excitement, it creates this orange-red color. And it's much dimmer than the other colors that are produced, because this is a low energy type of thing. And actually, if you're when I was reading, if you're directly underneath an aurora, you can't usually see any of the red at all. Usually you can only see it from looking at it obliquely. But here's a picture of the aurora taken from the International Space Station, and you can see, you know, the red at the top and the upper part of the reaches, and then the green, and then you get a feel for the three-dimensional structure of how these aurora actually look. And you know, it's interesting that the height of the aurora is the upper reaches of it's actually a little bit below the orbit of the space station, and so they actually fly above the auroras. And I was talking to one of the astronauts who said it was kind of weird being out on a spacewalk and just like looking down between her feet and seeing the auroras up, you know, coming up from below her. It was just an amazing type of thing to see. You know, we're continuing to learn about the auroras and things too. There was this phenomenon that was discovered in 2016, or was photographed for the first time, and they called it Steve, which stood for you know, high energy type of excitation. And it turns out that Steve is not actually an aurora. It's actually, we're still trying to figure exactly what it is, but it's some sort of plasma trail at about 450 kilometers. You know, it was first identified as a unique phenomenon in Canada in 2016, but it may have been seen as early as 1705 when I was reading about it. But then the most recent aurora discovery was a thing they call the dunes, which was first photographed in 2015. And this is kind of it's gravity waves of an atmospheric wave that's caught between thermal layers about 100 kilometers high. And so you can see the dunes kind of rippling there. That's actually the wave being excited by ions striking that. So we're still learning about auroras and finding out new things about them. And you know, of course, your Earth is not unique in having aurora. We've seen them around Jupiter. We've seen them around Saturn, and also around Uranus as well. The ones around Jupiter, the bright spots on there, which the circles as you see there, is that Jupiter's magnetic field is actually coupled to its moon Io, and so there's a bright spot in the aurora that is directly facing towards Io that follows it around the planet. And there are slightly dimmer spots that also follow Ganymede and Europa as well. So here's what the aurora looks like from space. And you'll see that it looks like it's a circle here, and it goes. There's an auroral oval around both poles. This is over Antarctica, as you can see here. And one of the things that you learn if you want to start chasing the aurora is you start figuring out how strong is the sun's activity, because the stronger the sun's activity is, both the more energetic the aurora get, but also the farther south you can see them. And so we start looking for a number that's called the KP number. And the KP number is an indication of the intensity of the geomagnetic activity that's going on. And the circles here you can see they're not completely concentric around the North Pole. They're actually concentric around the North Magnetic Pole. And so this is why we can actually see the auroras farther south in North America than you can in Europe, because the North Magnetic Pole is near Ellesmere Island, which is in the north part of Canada. So the auroras actually reach a little farther south here than they do if you were in Europe. But you can see here, so a KP3, that top circle on there, if you've got a reading of KP3, that means you'll be able to see, most likely be able to see auroras from there or farther north. Basically, if you're in that zone and it says KP3, the auroras will be overhead or farther north. If you're in the KP3 area or in that zone, and then the intensity goes up to KP5, you'll be able to see the auroras covering more of the sky. Yeah. Now here's an example of the KP zones. One of the other things about the KP that's interesting to know is that each zone is 10 times, it represents 10 times as much energy as the one above it. So KP1 is 10 times as powerful as KP0. KP2 is 100 times as powerful as KP0. To get down to KP9, you're talking about a storm that's 1 billion times more powerful than the baseline activity. So in order to be able to see the auroras in France, for example, or to be able to see them in North Carolina or Virginia, you're talking about a geomagnetic storm that's about 1 billion times more powerful than the baseline activity. So it is possible to see them, but it's a rare event, and it's usually associated with the height of the sunspot cycle. So if you want to see auroras, what you have to do is you have to go a place. You have to figure out what the KP level is going to be like in your area, or at the time of year for you. For us in a solar minimum, we're looking at KP0 and KP1 as being kind of the baseline activity level right now. So if you want to see the auroras, you're going to have to go pretty far north. And luckily, there are ways to do that. And you can go up to Alaska, you can go into Canada, or you can take a cruise. And I'll tell you a little bit about how we went on our search for the Northern Lights. By the way, this is the prediction for the aurora oval tonight from the outside looking up from the Aurora Prediction Center, and you can see the KP level right now is 1.65. So you'd have to be at the top end of Norway or pretty high up in Canada to be able to see the auroras tonight. And there's lots of apps that you can get. There's a Space Weather Live that will tell you what the current KP level is and the predicted probability of seeing the aurora and what the aurora oval looks like. There's the Glendale app, which is very scientific, will tell you what's going on in the solar wind and the Earth's magnetic field, and give you a much more scientific prediction. And at the far right here, these are screen prints from my watch. The Aurora Network even has a little watch app, and so I'm still getting notifications every once in a while that the aurora is visible in Norway, and makes me very jealous that I'm sitting here in North Carolina and not getting a chance to see that. So, if you want to go chase the aurora like we did this year, we took a cruise with Viking that started off actually with a couple of days in Iceland, hoping we might be able to see something there, and then we went a cruise that started in London and worked its way up to the very top end of Norway. So I'm going to show you a little bit about what the landscape looks like, and also what it was like to be looking for the auroras in the course of that cruise. So this was our first view of Iceland as we were approaching, and it certainly looked like an icy land. This was as the clouds parted, I saw this very bizarre-looking mountain, which I learned later on is called Ingolfsfjall. And it turned out that our hotel was right on the other side of this place here. But we went to Iceland. This was our hotel.
Nice.
Yeah, the sky was very interesting. Unfortunately, it was cloudy the whole most of the time, and so the clouds and the low aurora level, we didn't see any auroras when we were in Iceland. One of the things you can do at the hotel, and they also did on the ship, was that they said, do you want a wake-up call? And I said, well, we don't have to get up for anything tomorrow morning. They said, no, we'll call you and wake you up if there's auroras. And I thought, oh, what a great idea that was. But we never got the phone call, unfortunately. But Iceland was a beautiful country and very otherworldly. I just wanted to show you a couple pictures. This was one of the black sand beaches with basaltic columns around a cave. Just a very otherworldly. You can see why the Apollo astronauts went here to study geology before going to the moon. This is from that same black sand beach. Looks like something out of Mars almost. This is the national park in Iceland, and the jumbled landscape that's running through the middle of this is actually the rift zone that separates the Eurasian tectonic plate from the North American tectonic plate. So you can actually walk down here between the two in the rift zone area. So to the left of this picture is Europe and Asia, and to the right is North America. And this rift area in the center is expanding about 1 centimeter every year as the plates pull apart. So interesting place for studying geology. Unfortunately, again, we didn't get a chance to see the auroras while we were there. But so we got on board the ship and started heading up the coast of Norway and making good time to try to get north of the Arctic Circle, where we were going to have the best chance to see this. By the way, this started the last week of February and going into the first week of March. So this was our ship, the Viking Star, and you can see it was pretty cold in late February to go there. As you cross the Arctic Circle, they do a special ceremony of the blue nose to commemorate your crossing the Arctic Circle. You take a shot of aquavit, and then they put this blue stuff on your nose to prove that you crossed the Arctic Circle. It was a lot of fun. Just being that far north, I'd never been that far north before, and it was really fascinating. This is a picture taken at high noon, and the sun was 13 degrees high above the horizon. And they were just coming out of having been 3 months of winter, of darkness, and so the sun was actually rising about 5 minutes earlier every morning and setting about 5 minutes later every day. The days got longer a lot faster there than they do here when you're coming out of wintertime. And this is what an aurora hunting kit looks like. Basically, this is what it had to wear every time you went out. It was really cold. I think it was in the teens and 20s most of the time we were there. Lots of wind. Several layers of thermal stuff, ski pants, 2 layers of socks, 2 layers of gloves, 2 layers of hats. We got to be pretty adept at putting this stuff on pretty fast, though.
How did you move?
There'd be a lot of shivering that kind of kept you going. But it was funny. So this was the bed on the boat, and you had to keep a lot of this stuff right next to your bed in case you got the phone call in the middle of the night that the aurora was coming out. And so on the night of March 2nd, we got the first phone call saying the aurora is visible, and everybody of the 900 people on the boat went running up to the top deck, and none of us know what to look for. A lot of us were going along the side rails here, and you can see they were pretty brightly lit. A lot of us were staring over at the side at what we thought was the aurora, and it turned out it was just glow from a small town that was behind an island. So a lot of people stared at that for about half an hour and said, this is it, forget it, I'm going back to bed. And we were one of them. We went back downstairs, and then the call came again that aurora were visible. And so I thought, okay, well, this time I've got to try something different. And so I went up to the front end of the ship, not realizing that they had put red lights at the front end of the ship to protect your night vision, which was great. And the other thing that I hadn't realized as well either was that, of course, the aurora were going to be to the north of us, not over to the east or the west. So I needed to be looking north, which is the direction the ship was going. And so this was my first view of the aurora. And this was like about 1:30 in the morning. It was definitely, you could see there was something going on here. I apologize for I was trying to figure out how to do photos with my iPhone. I didn't have a tripod. everybody said, don't even bother trying to take pictures of it because it's not going to look like what you see. Let the pros take the pictures. But you can see that the moon is over at it's the bright object to the far left, and the Pleiades are just up to the 2 o'clock position from the moon there. But you can see there's definitely some weird color going on in the sky there. I was experimenting with different settings here, but you can see it by 1:38. There was this weird kind of curtain effect that was starting up to the northwest. Here's another picture at 1:45, and so this is kind of what it looked like to the naked eye. It was, and here again, you feel like you were looking at some sort of cloud, but it's just a very sharp rim to the bottom of the aurora, and this little ray was kind of forming off of it. And so that was the best view we had that night. And okay, this started whetting my appetite at this point. Now I could see it moving a little bit, but it was still not very high in the sky because we were just crossing the Arctic Circle at that point. And we stopped at a little town of Buda, which has one of the best air museums I've ever seen. If you ever find yourself up in that part of the world, it's a NATO base up there. It was where Gary Powers was flying in his U-2, was hoping to land in his U-2 when he was shot down over Russia. So they've got a great air museum up there. The landscape is just fantastic if you get out of town. This was about 4 o'clock in the afternoon there, but that night we got the phone call again at about 2 o'clock in the morning, and this was looking overhead. The first thing I saw when I got up, when I looked overhead, was I could see the Big Dipper, and it was like there was a hole in the sky that had all these rays coming out of it, and you can get a little hint of that here. The handle of the Big Dipper is at the very middle at the top. You can see Mizar and Alcor as a double star up there, but it was just this feeling of all these rays emanating down from this hole in the sky. And I think that's a formation they call the corona. And basically what you're doing is you're looking up at the sheet itself. These auroras are, they're tens of miles high, they're hundreds of miles long, but they're only a few hundred yards wide. And so the perspective of the angle at which you're looking at them changes how you see them. And so again, here's some of the way some of the rays were starting to move around. This one caught my eye because I could actually see this one moving, and I'm going to try to skip through it. This is in the course of about a minute. You can see this one just kind of scooting across the sky, and it was definitely, I could definitely see this kind of motion going on with it. So that was the other hand, some of the things were very gently undulating, but this one actually looked like something scooting, moving quickly and brightening in sections and elongating out. And then it was gone within another minute. But then 10 minutes later, here's in that same area, another one scooting along there. And that kind of surprised me that you would see the same. These things didn't move with the stars; they stayed in the same area, which I guess makes sense because of how they're aligned with the Earth's magnetic field. But you could see these were all. This is under Perseus here, but then the moonlight didn't seem to affect it. They actually said in some cases the moonlight helps you see them a little bit better. So the next day we docked in the town of Tromsø, and our ship is docked there at in the right of center of the screen there, and way in the back behind those mountains is where we went that night for an aurora expedition. You can either get a bus or you can take we had like a 12-passenger van that took us out away from town to where there was going to be a good chance that we might be able to see auroras, and they were actually predicting a KP index of 3 or 4 that night, so we thought it was going to be a good chance of seeing something. And so I'm going to just go through this one. This is going to be shot over the course of about an hour. Our guide said, he thought he could see something, and I got out, and it looked like there was this little thin wispy cloud to the north, and I couldn't tell if it was a cloud or not. But as soon as I held my phone up, I could see very brightly in the camera viewfinder that it was green, and I could see it much more clearly on the camera than I could with my eye, which really surprised me. I don't know if it was the sensitivity of the lens or what, but you can see, so this mountain here, you can see we're facing off towards the, you can see Corona Borealis rising there. So this is off at about 50 degrees, 50 degrees azimuth from where I was standing. And so over the course of the next few minutes, you know, there was a little bit of activity going on there. You can see some things starting to form, a little bit of curtain type of activity forming. And then over in the other, this is looking over to the west, and then suddenly it got very bright over towards the west behind this one mountain. And there's the Pleiades there, and you could see they set up this little campfire and a little bench in the snow. The snow is a couple feet deep here, and so you can see.
It's made from the snow.
Yeah.
The bench was purely snow. They were able to flatten it up just within seconds.
They packed it down and put a piece of rubber on top for you to sit down on.
Right.
And it was, the wind was blowing at about 40 miles an hour. It was very cold out there. But, you know, of course, when suddenly now the aurora starts looking like this, and this is very much what it looked like to the naked eye. It was very bright. You know, you could see it moving a little bit. It was definitely changing shape. Every time you turned around, it was slightly different shape. And again, these are all handheld exposures, but you can see how the shape is changing over the course of a couple minutes. It was just you know, you're looking back and forth across the sky and overhead, the same kind of thing with the rays coming down. You know, we didn't see, Jane, I don't know, did you see any colors other than the green?
No, just different shades of green.
Yeah. That was
and
go ahead.
And the pictures all look different, but in reality, they just look sort of like a continuum of you know, of the green. Like this one is mostly white, but if you look at it in real life, it was more green.
Yeah. Yeah, over on the left hand of this picture, this is actually snow blowing off a mountaintop off to the side, and the moon is lighting that up. Yeah.
That's cold.
Yeah, it was.
But yeah, you can see the Pleiades there and Taurus and everything, but it looked almost like a volcano with this green smoke coming out of it. And then it started kind of curling around, and you got this interesting curlicue effect on one side. But you can see they're all coming from this same mountain here. They, you know, it didn't appear to move relative to the background. It all stayed behind that one set of peaks there, even as the aurora curled around and made these interesting shapes. And so here now it's this is about a half hour after the show started. And you know, it would start to peter out, and then it would start getting back up, coming back up again. You get these interesting folds in the patterns there. You know, little bits and pieces would appear and disappear. It was one of those things. I felt like a kid on Christmas, kind of just watching the thing move around. And again, this was not a particularly energetic storm. When we asked the guides afterwards, of course, we were just all blown away by what we'd seen. And we asked the guide and said, you know, what did you think about that one? And they said, well, this was, you know, slightly better than average. But of course, for us, it was great. This was looking overhead, looking up into one of those corona things. Again, the kind of the rays shooting down from the Big Dipper there. It was just, yeah, it was just mesmerizing to sit there and just watch these shapes move around very slowly. Again, this is over the course of about an hour that we're looking at these pictures here. This one, so our friends Sheila and Ron, let me go back to this, are over on this picture, and I found another picture that our guide took almost exactly the same time, and you can see. So let me go back here. You see the shapes are relatively similar. I think Sheila and Ron were about 6 miles away from where we were, so it looked pretty similar. But you know, if they'd been farther away, you might have seen slightly different shapes in there.
Very exciting.
Yeah. So I found where we were on Google Maps. And so the two mountain peaks are at the end of those two lines there. So that's pretty much the same direction that the aurora stayed that whole night, was along that thing. So I guess if I was going to go back and look at the magnetic field, that would probably be, I'm assuming that would be the rough orientation of the magnetic field that night.
And it was straight overhead because, you know, some of us were laying back in the snow, kind of like with snow angels, you know, and looking overhead at this just beautiful strip, undulating ribbon above our heads. It was just great.
Cold.
Yeah.
They had hot chocolate for us, and then reindeer stew.
Yeah.
Reindeer stew.
Reindeer stew. Yeah.
Yeah.
How was it?
It was good. It was actually very much like beef stew, kind of.
Ah, good.
Yeah. It's like beef stew.
Yeah, like beef stew. Yeah. So the next night there was another aurora display, but we were in the middle of a large town and you couldn't really see very much of it. And unfortunately, we didn't know that was going to be the last night that the aurora were out. We went a little bit farther north into the east to a town called Alta, which is where some of the research stations are. They have the Cathedral of the Northern Lights there, which is made out of titanium, and the inside of it has actually got this interesting aurora type of lighting display in there. That night we were supposed to go out to an aurora observatory, but you can see it was very cloudy and it actually started snowing that night, so we did not go out. That was our last opportunity. So, you know, we were very fortunate. We had 3 good nights where we were able to see the aurora. One, it was a really fantastic night. The next day we took a reindeer ride, which, as you can see, bundled up here. And this is reindeer stew, in case you're interested.
Which is kind of sad when you think about it. They're carrying us
Right.
around, and then we eat their brethren, you know, for dinner afterwards. It's just very depressing in a way, but interesting, unusual.
Yeah. Anyway, that was it. It was a great experience. We're really glad we got a chance to do it. You know, the Northern Lights were something that were always on my bucket list of things I wanted to see. And I had a friend who was a resident astronomer on another cruise, a couple other cruise companies, and he'd been on 3 other cruises this winter and had not seen any until that same week that we were out. So we were very fortunate that the timing worked out like it. We were able to see it. Yeah. Sheila and Ron, what were your impressions of the aurora when you guys saw them?
Oh, we were so excited. We just couldn't believe it that we were really finally seeing it. You know, because living all of our life wanting to see them and finally seeing them, it was unbelievable.
Yeah.
And still, we're still excited about the fact that we did.
One thing that was so exciting, we were getting back in the van, and the guy on his phone, you know, the app he had, he says, "Oh no, they're coming back, and he got so excited, he set his camera up, and then the ones on that mountain in the back there that you got where it looked like it started to go on fire and stuff, it was beautiful. It just,
Yeah.
so anyway, it was great.
Very special.
And another thing I really liked is on the reindeer above the Arctic Circle, the girl, she said, "This is my home, but you're going to go to my house and have some reindeer stew," you know. So I love that. I love.
Yeah. It's a great opportunity. If anybody ever gets a chance to do that, I strongly recommend it. I understand that there are some great aurora trips in Canada as well. That's supposed to be, I guess, even better chance of seeing them sometimes if you go up in the Northwest Territory area of Canada as well.
And Jonathan, that presentation you did, I wish they'd have had something like that on the ship prior to us. You did it. So if you do go to Alaska and do that, I love that presentation that you
did. Yeah.
Thanks.
that you did.
Yeah. It was we really had no idea what to expect, because most of what you see is
did it. That was wonderful.
Most of what you see is time-lapse images or long exposures, and if you take anything that's longer than 3 or 4 seconds, the images blur, and so it really doesn't look like what you're seeing. there's one great video out there. I didn't want to share it because of the bandwidth concerns here, but there's one where a guy, I think it must have been during a high intensity geomagnetic storm, but you can actually see the things like swirling around and changing colors and flashing, and the guy is practically breathless. He's so excited to see that. But I would highly encourage you to Google that. I think it's on Phil Platt's website. Okay. Well, so that's what I did for my vacation. Jane and I were scheduled to fly back on the day that the president announced the travel ban. So we got back to Greensboro Airport. I dropped Jane off and went out and stood in line to get bread and milk and things like that before the store shut down. So.
Yeah, we feel lucky that we made it just before.
I know.
Yeah.
Can you get toilet paper yet?
No.
We did, actually, finally.
We did get some
Ron got
ceramic.
up really
I
early.
don't understand that.
He had to go in at the seniors hour. It's from 7 to 8 to get some toilet paper.
Wow.
It's crazy.
Welcome back to civilization.
Yeah.
Any questions? Yeah. Any questions from anyone?
No, I just I love the
The history.
and
getting
then
the
you
history.
you showing those satellite spaceship from the showing the effects of it. I wish they'd had something like that when we were on the ship.
I think that's why they're going to have him doing it.
Yeah.
I think he's going to be better than what we were getting. Yeah.
Thank you, guys. I appreciate it.
Did the cruise go up? Oh, sorry, go ahead.
Go ahead. Did the cruise what?
Did the cruise go up rivers, or were they, because they look like lakes to me?
It was kind of like inland. It was kind of like the inland waterway. There's some
Fjord.
protected passages that you can go up in between islands and things like that. Sometimes we were out in the open sea, but a lot of times we were going up between islands and things.
It was absolutely beautiful through there.
Yeah, it was a lot. I thought it was going to be pretty rough, but it actually was pretty good. I never got seasick the whole time.
Mhm.
I noticed that the stew had like a spoon handle that looked like about that long. Was it, or is that just an illusion?
It could have been up close. I think they made it out of it was wood. I think, yeah.
Mhm.
Bone.
Yeah.
I think that was just for show for us.
Yeah.
That's it.
I think that-
It was not.
everything-
It probably was. It was probably really beef stew, and they just called it reindeer stew.
It sure tasted like beef stew.
Yeah.
I was surprised, and they talked about it like it was something fantastic. I thought, oh my God, it's just beef stew.
But it was hot, and
It was hot. Yeah,
it
that
felt
helped
good.
a lot.
I know. It was nice to have that and any tea or whatever they would give you because it was always cold.
All right. Well, this would normally be the time when we would go downstairs, have our business meeting, but I don't know if we have any business that we need to